This is intended to be a follow-up on Session 1 using the example from Arif's palliative care trial. As you'll recall, Arif's study had two aims. First, to describe the adherence to 20 measures of quality palliative care. Second, to determine which of those 20 measures is most strongly related to patient outcomes, such as symptom burden and 30-day readmission rates. These two aims already reflect some translation of his ultimate goal, namely to find the 5 things that he should do in every palliative care consult. We'll stipulate that they're close enough to his original goal to be able to proceed. For aim 1, one important decision is whether to look at one measure at a time or instead to try to group them. This is a depiction of the portion of analyst's story of how the analyst's story would look if we looked at one measure at a time. The denominators differ from measure to measure because not every patient will be eligible for every measure. This presentation answers the question, overall, how adherent are palliative care providers to the various measures? This is a visual depiction of the portion of the story that answers the question of who adheres to which measures. The subgroup variable defines the who. For example, the subgroup could represent site, specialty, a patient characteristic such as age or type of diagnosis, and so forth. This depicts the data array that would feed into the analyst's story. You need to know the structure, the type of variable, and their scale of measurement. The structure is one record per person. For each measure, say for the outcome variable is adherence. Yes, no, or not applicable. So for adherence measure 1, I've written down a Y for the first patient, an N for the second patient, and a not applicable for the third. This whole structure is repeated for 20 separate measures. I didn't include the input data to those measures, but in practice this is the point where you'd ask whether the available data fields are sufficiently comprehensive and accurate to allow you to be confident about your classification of adherence. The predictor variables are the same variables that are used to define the subgroups. By the way, if there are lots and lots of measures to consider, it might be simpler to start with some separate data sets and then combine them into this structure for analysis. For example, the predictor variables might be collected in one data set. Variables for each adherence measure might be collected in separate data sets, or in one data set that has one record per patient per measure rather than one record per patient. Data don't have to be collected in the same format in which they'll be analyzed. They just need to be collected in a format that can be appropriately restructured. For aim 2, we can work with a similarly structured data array and simply add the patient outcomes as additional fields. This is a depiction of the portion of the analyst's story that answers the question of whether adherence to measure 1 matters. When the outcome is continuously scaled, such as symptom burden, the visual is box plots for adherent patients and a separate box plot for non-adherent patients. The statistical test to use is the t-test. When the outcome is dichotomously scaled, such as the presence or absence of a 30-day readmission, the visual is a 2x2 table, and the statistical test to use is a chi-square test. The analysis would become more complicated if we tried to take advantage of patterns among the measures. For example, if we tried to put all the pain-related measures together into a single summary of how well providers were tending to this dimension of care. That's more detail than we need to get into for now. Suffice it to say that the input data array would be the same. A final comment on how to figure out which statistical test to use. Statisticians organize their thinking according to scale of measurement. This slide illustrates how statisticians think about models with a predictor and an outcome, where that outcome is a single continuously scaled variable, such as the response to a pain scale. Some patients call all of these models regression to denote the fact that the outcome variable is continuous. But more typically, there's an additional distinction based on the number and scale of the predictors, as illustrated here.